This is section 5, definition of a derivative, example 2. So when we learned about the definition of a derivative, we learned about it with respect by looking at the equation, right, and looking at a graph and seeing, okay, well, I need that horizontal distance for my slope to get smaller and smaller and smaller and smaller and smaller. And the only way to do that is by taking a limit. Well, there's an alternative definition of a derivative where it looks more like the slope formula. And that's what you see at the top of this page. F prime of a equals the limit as a approaches x of f of a minus f of x over a minus x. You are responsible for knowing both of them. Okay, now most of the time when you use these definitions, you're not going to be told use the limit definition to find the derivative. Okay, there's actually other ways to do that, which we're going to look at next time. But what they will ask you is something like in example 2. So they'll say, find the limit as h approaches 0 of sine of pi over 3 plus h minus the square root of 3 over 2 all over h. And your job is to figure out what they're asking you, because they don't expect you to do that by hand. Because if you look at these problems, there's not really a way to simplify these things. You have to know what they're asking and then use a shortcut to do it. Now, I haven't shown you the shortcuts, so our jobs in example 2 for now are just going to be to figure out, well, what formula are they using? Are they using the original one or this new one? And two other things. What derivative are they asking me to find? And at what point? Okay, so first, we know, so I'm just going to write it up here. The original is f prime of a, what's the limit as h approaches 0, f of a plus h minus f of a all over h. Okay, so there's two forms. There's the limit as h approaches 0, and typically it is an h that they use. Typically, right? It's not limited to that. It could be any other variable. But when it's just divided by h, or when h is going to 0, oftentimes, not always, right? If you look at A, B, C, and D, they all have the letter going to 0. Oh, B should be going to 1. Sorry. But anyway, the first thing that they're giving you is the function. Okay? The second thing they're giving you is the function with the number plugged in, most of the time, right? But between the two equations, the second one of them is going to be the function with the number actually plugged in. Okay, so when we go down here to example 2, we can see, oh, well, that's the limit as h approaches 0 all over h. Okay, and then we have pi over 3 plus h. That means we're using the first form, the original definition of a derivative. Okay, just so you start recognizing what it looks like. And the normal definition of a derivative is f of x plus h. So if it's pi over 3 plus h, then the x is pi over 3. Okay, that's it. The x is pi over 3. So it's asking us to find f prime of pi over 3, where f of x is some function, right? Which we can see. It's the sine of pi over 3 plus h, which means our function is just the sine of x, because pi over 3 plus h is plugged in to f of x. So that's all we need to know for now. Later on, I will actually have you take the derivative and plug things in. But we don't know shortcuts for trig functions yet, so we'll get there. For b, sorry, this is a typo. That should be a 1. A is approaching 1, not 0. We're finding the limit as a approaches 1. Well, if it's a minus 1, right, and we're plugging it in, then that means that we're actually using that top equation, the one that's on this page, the new equation, all right, where it's f of a minus f of x. So if it's f of a minus f of x, then they give us the equation in that first term. So we are finding the derivative of arctangent. So the f of x function is arctangent. And we want to find f prime of a certain number, which happens to be the number that a is approaching, right? Because that's the number you're going to plug in. So it's f prime of 1. That's what we're trying to find. For c, it's 8 plus h on the inside of a cube root, which means that we're trying to find the cube root function. Okay, because the cube root is the 8 plus h. The number we're trying to find the derivative is given by this right here, the 8, because it's x plus h. So we're trying to find f prime of 8, where f of x is the cube root of x. Okay, because if you go to plug it in, we would get the limit as h approaches 0 of the cube root x plus h minus the cube root of x all over h, and then you'd plug in 8. When I plug in 8 for x, this becomes 8, and that becomes 8, and the cube root of 8 is 2. So that's how you get from here to that problem that they gave us. And then for the last one, that is supposed to be a approaching 0, right? And this one's a little tricky. It could be either one, because there's only a on the bottom. So we don't really know just by looking at it as quickly. But you do know by looking at it, only because there's still a, okay? And really, there's in the equation e to the 2a, there's no a plus h. There's no number plus h. It's just 2a, which means it's that second form that we're looking at, which gives us the function in that first term, which means that f of x is e to the 2a. And that means that this number is what we're finding f prime of.